A digital elevation model is the starting point for terrain analysis. This video is going to talk about what a DEM is, what we can do with it, the various types. We're going to learn how to symbolize DEMs, and then we're going to learn about the other data sets and analysis that we can derive from a digital elevation model, such as slope, aspect, contours, and so forth. We'll also learn how to interpret these elevation data sets so that we know what it is that we're looking at on a map. When we first add a digital elevation model to ArcMap or another mapping program, you will see what you see up here in the upper right-hand corner. It's a grayscale image with going from black to white. The black areas are lower elevation while the whiter areas are higher elevation. If you click on this digital elevation model at any point, it will show you the elevation of that particular pixel. So a key thing to know about a digital elevation model is that it's raster data. It's essentially an image, and each pixel has an elevation value associated with it. Another thing you have to be aware of, because it is raster data, we have a particular resolution associated with it. Common resolutions for DEM data are 1 meter by 1 meter data, 10 meter by 10 meter, and 30 meter by 30 meter. Obviously, the smaller the number, the better the image is going to be, or the more crisp it's going to be. The higher the resolution, the less detailed it's going to be. So just think about what this means before we move on. If we are thinking about the Earth, where we're standing, 1 meter by 1 meter, that particular square has one elevation value assigned to it. If we have a 30 meter by 30 meter pixel, that's 30 meters on the ground square, and that has one elevation value assigned to it. So we can understand why that might not be as crisp looking, because we are really generalizing the data with that. So we're going to learn how to find and work with two different types of digital elevation models. The first are going to be the USGS digital elevation models. They're the ones that are 10 meter by 10 meter in resolution. They are based on the USGS quadrangle, and this has nationwide coverage. So the benefit to these is the fact that there's coverage for the contiguous United States. Another program that we're going to look at is the PA map program and the DEMs that were collected as part of that. This data is 1 meter by 1 meter in resolution, and each DEM is 10,000 feet by 10,000 feet. So let's look at these and compare the extents of these particular digital elevation model programs. And let me turn this one on, and let's zoom out a little bit. Okay, so what we're looking at here, this is an area of Lebanon County, and I downloaded two different digital elevation models. I downloaded the USGS digital elevation model along with the PA map one. Notice, and I'm going to turn my townships off now, if we zoom in to the Indian Town Gap extent, we see this little box over it, which is the PA map one. And look what happens when I turn the PA map one off. You can see that underneath it gets less detailed, and I think this is even more apparent if we compare the shaded relief maps that were generated by each, so that you can see the different in crispness level. This image that's on top is the PA map digital elevation model, and notice how you can see a lot of little detail within this particular image. If we turn that one off and look at the one underneath, we can see how much more generalized that is with the various features, and that's the 10 meter by 10 meter. And what's really kind of neat is if you can turn on your effects toolbar, you can grab your swipe tool, and it's kind of a nice way of comparing, because you can kind of just move things back and forth. So if we look at like an area on the map where I'm swiping, you can definitely see a big distinction in the quality of the digital elevation models. But quality comes with some trade-offs. Because these are 10,000 feet by 10,000 feet, we have thousands of these for the state of Pennsylvania. So, and they're a higher file or larger file size than the topo maps or the USGS DEMs. So let's look at the spatial comparison of the various programs. So what we're looking at here is obviously Lebanon County, and the dark red line are the USGS DEMs. So let's say that we lived right here and we wanted to get the digital elevation model for that area. We would simply click on our identify tool and identify this particular box, and we find that it's the Indian Town Gap a digital elevation model, so we know that's the one that we would need to download. Same goes for if we turn on the PA map South Index. Notice how many more of them that there are. If we want to identify it, we have to click on it and we get the number that we would need to download. It's the tile ID is what we would need. Again, you know, the high quality data comes with some drawbacks. If you wanted this same area for PA map, you would have to download all these DEMs, which can be quite time consuming. There are digital elevation models from the PA map program at the county level, so you can actually download a county mosaic for the whole county and then just clip off of there. But just to give you an idea of the spatial extents of the various programs. So where can you find these digital elevation models? The USGS DEMs can be found at a lot of different places. Probably the best place to get them from would be directly from the USGS on their national map viewer, but you can also get them from POSDA, which we learned how to use earlier in this course, and a site called GIS Data Depot. And I'll show you where to find these on the POSDA site when I get there in a minute. For the PA map DEMs, we can find them on POSDA, and there are various ways of finding them, and I'm going to show you the easiest way so that it gives you less headaches. The imagery navigator is definitely much easier to use and much more friendly than going to the FTP site. That can be a little intimidating unless you're really used to working with it. So with that, let's go to POSDA to see where these digital elevation models are located and how we can find and utilize them. So we're at the main page of POSDA. If you click on the LiDAR and elevation shortcut, this will get you started in getting the data that you need. For the PA map project, the data link that you need is this one, the PA map program 3.2 foot digital elevation model. If you want the USGS DEMs, we have to scroll down, and they are located right here. We have both the 10 meter and the 30 meter from USGS. If you click on that particular link and go to download, it has all of them listed by quadrangle name, and we identified that we needed for the Indian Town Gap one, so you just scroll down till you see Indian Town Gap and you download it. And I'm actually gonna pick another one from Lebanon County because we already have that one. We'll take Fredericksburg. So let's go back to this. Click Fredericksburg, and it will download that particular DEM, and we'll get back to that in a minute. The other place where you can get digital elevation models is from the PA map program 3.2 foot digital elevation model. We go to download and then PA map LiDAR, and this gets a little convoluted, so you have to be patient with this. Cycle 1. Now, I'm going to go to DEM mosaics first because this is probably going to be the most helpful to the most people. If you click on DEM mosaics, it has the mosaics for each county in Pennsylvania at a 1 meter pixel resolution and a 3 meter pixel resolution. So you can get the whole county one shebang this way, and that's what I would suggest because it's a really easy way to get started with things. If you want to be more precise, you can go to the DEM folder, and since we use the South Index, we're going to select that. And then we have to know what year it was flown. I happen to know that it was 2008. So if we identify a particular picture here, we're going to take 4100 2320, and we can go and download that image by going back. Because the number I wrote down begins with a 4, we select the directory that begins with a 4, and then we can do a control find, just type in the number that we need, so 41002320, and we can download the data. So this is the hard way of doing it, which is not the way that I would necessarily suggest. I would suggest going with what we learned in a previous module when we learned how to use the Pennsylvania Imagery Navigator. So if we go to the Apps and Tools link on POSDA, go to the Pennsylvania Imagery Navigator, and I'm going to zoom into Lebanon. And if you read at the bottom here, it says right-click on the map to download an image file. So I'm just going to pick a place in Lebanon County to right-click on. And where I right-click, it comes back with every single imagery piece of data for that particular place that I just clicked. So if we're interested in elevation, we click the last option, Maps and Elevation, and you'll see that you have the PA map download here. You have the USGS download here, and then you can also get contours and break lines and so forth. So this is probably the better way of doing it, and the way with the least amount of headaches to get the digital elevation models that you need. So that's a little bit about how we find the DEMs that are appropriate for our study area. Now, you probably noticed that there are some different formats associated with raster data. When we download this data from or from POSDA, a lot of times it's in a TIFF or a SID or JPEG format. So you're going to see those associated with it. You might also see IMG associated with some raster data sets. When we start creating rasters within ArcGIS, like when we start creating slope maps, aspect, and so forth, the default raster format in ArcGIS is a .grid. So it's just something to be aware of, not going to really worry about too much, but just know what you're getting when you're actually working with these particular data sets. So in terms of understanding DEMs and interpreting them, if we look at this map here, and let's just look at the PA map one first. We see that we have a low value and a high value. The low value is the lowest elevation within this particular digital elevation model, and the 1255 is the highest. So that's the elevation range. In the Fort Indian Town Gap digital elevation model, it's from 108 to 416. Now, one thing I'm hoping that you're asking yourself is, well, that's great, we know the range, but what are the units of the range? Is it in feet? Is it in meters? How do we know? And the way that you know the units of your digital elevation model, and you can do this a couple of different ways. You could read the metadata that comes along with it, and that will tell you immediately what units it's in. But if you don't want to do that, or you can't find the metadata, if you simply go to your layer properties and go to the source tab, this is going to give you all sorts of information about your raster data set. So we can see the cell size is 3.2 by 3.2. If we keep scrolling down, we see that our units are in feet. So each pixel is 3.2 feet by 3.2 feet, or 1 meter by 1 meter. So that's how we figure that out. So the PA map digital elevation models are in feet, and if we look at the USGS digital elevation models, we see that the cell size is 10 by 10. If we keep scrolling down to look at the units, we find that it's in meters. So you really just have to be cognizant of your units, because you could really miscommunicate information about elevation and so forth if you don't know what units that you're actually working with. So that's a little bit on the interpretation of the digital elevation model. Now, there are certain color schemes that are appropriate for symbolizing digital elevation models, and some of them you may like and some of them you may not like as much. So what we can do to symbolize these is we can double click on them, go to the Symbology tab, and then in the color ramp, if you click on this, you probably would have no idea which one is an elevation color scheme and which one is not. So a little trick we can do is right click on the color ramp and select graphic view, and then it changes from the colors to the actual name of the color scheme. And if we scroll down, we see that we have elevation 1 and 2. So if I hit that and hit OK, that will symbolize it using an elevation color scheme. And I'll select the different one for the second, so you can see what they each look like. I tend to like this one a little bit better because I think it looks a little bit cooler over a hillshade, which we're going to learn how to create in just a minute. But that's how you can symbolize DEMs. Keeping them that black and white grayscale isn't really appropriate. You should pick up that color scheme to represent elevation. So with this, what we're going to do is we are going to learn how to generate other data sets from digital elevation models. As I said, a digital elevation model is a starting point for terrain analysis. So what we need to do before we can generate these data sets is we have to turn on an extension that will give us the functionality to work with these tools. The functionality for these tools is actually located in two different extensions. It's located in the 3D Analyst and Spatial Analyst. So as long as you have one of those, you're fine. I always just keep them all on. If yours isn't on, you have to check it to get access to those tools. So let's go then to our toolbox to look where these tools are located. And it's just taking a second. So we can access these tools in 3D Analyst tools. Under Raster Surface, we have the tools. We also have them in our Spatial Analyst tool set under Surface, and you can see the same tools. I'm just going to use the ones from the 3D Analyst toolbox. So the first data set that we're going to create are contours. As many of you know, contours connect areas of like elevation. So if we double click on the contour tool, the contour tool will open, and we have to tell it what DEM that we're creating contours for. And I'm going to select the PA map digital elevation model. And then we have to tell it where we're going to save it. I tend to, when I name these, I tend to put them or I tend to name them by the contour interval. So I'm going to call this contour, and I'm going to do contours of 50 feet to start out, to see how that looks. And I hit save, and then I put in 50 here. So then I can hit OK, and you're going to see the tool running down here in the corner. And these can take a few minutes sometimes, depending on the size of the data set. And unfortunately, we had, it did not work. We got an X. So that just means that we need to run it again. We can also look in our results area to see what went wrong with it. And it's just saying that I had invalid parameters, so I likely just messed something up. So I'm going to try that again. And again. Okay, success this time, and I'm going to actually turn on the DEM that's the contours for and zoom in. You can see that we have our contours. We can change the color to something maybe a little bit better than green. And another thing we can do is we can label our contours by the contour interval. To do that, you just go into Properties, go to your Labels tab, and select Contour as your label field. And then you have a map, a very basic contour map. So when you generate contours, you're actually generating a shapefile. You're creating vector data, line data. That's going to be different than all the other data sets that we're going to be generating. A slope, aspect, and hillshade are all raster data sets. So let's create some of those. So again, to do this, we go back to Arc Toolbox. And the next one I'm going to create is a hillshade. A hillshade is a shaded relief map. So when we run the hillshade, and I'm just going to keep it called the default, we essentially input the raster, we call it or output something meaningful. The azimuth and altitude is essentially where the angle of the light source is, and then we can hit OK. And you can see that we now have a hillshade map. And again, it's really giving you the relief. Now, a really cool thing that you can do, and something I like to do quite a bit, you can pull that DEM on top of the hillshade, and I'm actually going to change the color scheme to the other elevation, because that's the one I like a little bit better. You can set a transparency on the DEM so that you can also see so you get the color of the DEM but the relief of the hillshade. If we then go to our display tab and set a transparency on the digital elevation model, I'm going to start with 65. What you kind of see is now you have the effect of both. And this is what's called a painted relief map. And these tend to be really kind of cool and a little bit more useful than just one or the other. The combination of them tends to be really helpful. Even more helpful then is putting on your contours over top of this so that you also have that information. So that's some of the ways that we can combine these different data sets to produce output that might be meaningful and useful for a number of different purposes. So that's the hillshade tool. The next tool is going to be the slope tool. The slope is how flat or steep something is. So again, the input raster would be the digital elevation model. It's always going to be the digital elevation model. You name your data, your output raster, where you're saving it. And then something that you really have to be cognizant of is what output measurement are you using, degrees or percent rise. You need to kind of keep this in mind because when you go to make a slope map, in your legend, you have to tell it what units your slope is in. Is it in degrees or percent rise? I always just stick with degrees, and then you hit OK. And now we have a slope map. And what this is telling us is that the green yellowy areas are more flat, while the red areas are the more steep areas. So that's how you would interpret this particular data set. Another data set that can be generated is what's called aspect. Aspect shows the direction of slope. So if we input this, all we do is have to input the DEM and call it something. I'm just keeping default names for now. And this will run. And what's going to be interesting is the legend that comes back to us. While this may look very psychedelic, what this is telling us is what direction the slope is facing. So like all these pink areas are a northwest facing slope. All the green areas are southeast facing slopes. And this is really important to farmers and agriculture, because this can help them know where to plant crops, because if a certain crop does well on certain slopes or certain aspects, you can figure out where those are and then, you know, put your various crops in that particular location. So that is the aspect tool. So all of these tools can help us in understanding a particular area and the effects of terrain. In the exercise that's going to follow, it's going to have you generate some data sets that might be useful for your particular township, so that you have data that you can always go back to. One quick tool that I want to show before I leave off is the image processing window. That I have it docked over here. However, to turn it on, you have to go to Windows Image Analysis. This is a one-stop shop for imagery, and it's really kind of neat what it allows you to do. And I'm going to turn off all my data sets over here, so that I have a blank map, and you'll notice that those same data sets are listed in here. To work with any of these, you just have to highlight it, and it makes it active, and then it tells you what tools you're able to use down here. The one that I like using quite a bit, because it's really a quick way of making that a shaded relief map, is this shaded relief. So you highlight the DEM, and then click shaded relief, and I have to actually remove the transparency that I put on the DEM so that you can see that a little bit better. And now we have that really quick and easy. So it's a little bit less steps than what you have to do through ARC Toolbox. But there's a lot of tools in here that help you work with your imagery and play around with it, and that will be a lesson in an upcoming module.